Alright, so we have a question, length of loop in linked list. So the thing is that till now we talked about how to, you know, detect a cycle, how to tell from where it starts from. Now the thing is that we have to detect the length of the cycle. Yeah. In earlier question, I talked something about the length. You know, I mentioned earlier like a variable c, that is length of the cycle. So yeah, that's something that we have to now find out what's it about. So I would say pretty simple approach for this question. Um, wait, yeah. So how do we start with this question is, first of all, you know, the one thing in a linked list question is to find out the fast and slow pointer. That's something like where these pointers meet and everything. And yeah, if these pointers meet at a certain position, then let's see what we can do with it. Yeah. So for example, in the cycle my pointers meet at a particular position. Now what I can do is I can say, cool, you met at a particular position. Now one of you start to move ahead till the time you don't meet again. And the moment it's gonna move ahead, I'm gonna take account of it. Right? That's how it is. I'm like, alright, you guys met. Now one of you start to move ahead. Then obviously if you met inside the cycle, you can't go out of the cycle, because yeah, it's a singly linked list, so it's gonna be like going in cycles. That's it. So I'm like, alright, both of you met at a particular position. Now one of you start to move one by one. The moment it goes to the next node, I'll be like, add one. Next node, add one. Next node, add one. If we meet again, I'll be having the length of the cycle with me. So how do we do that? How do we do this question? First, basic approach, uh, that is fast and slow thing. You know, fast is at head. Let's copy paste it. Below our slow is at head. I'll be like, while fast is not equal null, and fast dot next is not equal null. What you have to do is fast equals fast dot next, slow equals slow dot next. That's it. Yeah. If they don't meet, keep going ahead. Yeah. If they meet, while loop will end when they will meet. No, I don't think so. Wait. Uh-huh. If fast equals slow, return that node. Yeah, return any one of them, and else if there is no cycle, I would say return null. Return null for the time being. Now we can say that this is our function, that is cycle list node cycle. Then I have this node fast and this node slow. this. Yeah, let's forget them, my bad. Yeah, so list node 1 can be let's call it cycle node. Yeah, from cycle node I will be putting in head and head. It's gonna give me the list, like the point where they met, and yeah, list node 2 can be same cycle node, I would say, as 1. Yeah, now the thing is that in order for them to meet again, at the moment they are at the same node. So how do I say something like while they both are not equal, run the loop? Because my loop is gonna be equal. How can I say while, wait, let me make int count. Yeah, so how can I say that while you two are not equal, keep moving ahead? I can't say that. And the moment you get equal, stop. Because the thing is they're initially equal, so I need something so that I get them to move ahead for once, and then I just know then they are not equal, so just be equal when you are equal. So then what we are gonna have right now here is do while loop. So do one thing, that 1 equals 1 dot next count plus plus. Do this while 1 not equal to 2. Yeah, I'm saying do 1 equals 1 dot next, just move it ahead till the time, and increase the count as well. And when you have done that, because the do while loop will be getting executed once, minimum for once it will get executed no matter what. So I'll be like, yeah, do this, and now have the while condition while 1 is not equal to 2, which it is not right now. Just move ahead, that's it. While 1 is not equal to 2, do what? 1 equals 1 dot next count plus plus, and then at the end return count, then at the end you can just return count. That's it, when the while loop ends, of course. How about this code? I guess it looks fine. Let's handle one edge case, that if 1 equals null, because it can get a null, then return 0. That's what they said. Yeah, it accepts, of course. It works. I guess I can't submit on the site because I don't have the premium, but yeah, I guess this works. Yeah. Okay, that's fine. Is this code right for length of the cycle? Let's go to the cycle, just correct, let's break it down. Yeah, okay. Cool. Edge case is handled, no cycle returns 0. Single node cycle, point switch cell returns 1. Wait, have I handled that? I mean, yeah. I guess, because the do thing handles it. Yeah, the do while thing handles it. Do thing make sure my count gets 1, so it returns once. Yeah, so cool. I guess my do while loop handle that edge case if there is only one node present. So yeah, this is something important. Its proof is very crucial in order to understand how these things work. Alright, so that's the code for it. It's right. So yeah.